Good afternoon, dear students. Previous class we discussed Unit 4 Hydrogen, Introduction of Hydrogen and Position of Hydrogen in Periodic Table, and what is the similarities between hydrogen and alkali metal and hydrogen and halogens. Today's class we are going to discuss isotopes of hydrogen, ortho and para hydrogen, then the preparation of hydrogen. What are the preparation of hydrogen? First topic, isotopes of hydrogen. So in isotopes, hydrogen contain three type of isotopes. One is naturally occurring isotope and another two are chemically occurring or laboratory preparation of isotopes. So the types of isotope of hydrogen, first isotope is protium. So protium is denoted here 1H1, okay, or otherwise we can denote this like this, or hydrogen. Okay, so we can denote first isotope of hydrogen, protium, 1H1 or hydrogen. So what is the second type? Second type is deuterium. Deuterium, and we are denoting this as 1H2 or otherwise denoting as D. Third isotope of hydrogen is called tritium. It is denoting here as 1H3 or T. Okay, hydrogen, we can denote this as hydrogen protium. First isotope of hydrogen, protium, and we are denoting here H. Deuterium D, first letter D, and tritium T. First isotope of hydrogen, protium, is naturally occurring isotope. Naturally occurring isotope in earth, it contain in our earth 99.985%. So you can the total amount of hydrogen 99.985%, it is protium. It contains one electron, and the structure of protium is nucleus and one electron. This is protium, or otherwise we can denote this as hydrogen, H. And it does not contain neutrons. Second isotope is deuterium. It is a heavy hydrogen. Another name of deuterium is heavy hydrogen. It's heavy hydrogen, and its constitute, we can occur this 0.015%. And the structure of deuterium is in the nucleus of deuterium, it contains one proton and one neutron. One proton and one neutron. And in the orbit, it's contain one electron. Okay. And the third isotope of hydrogen, tritium. It is a radioactive element or radioisotope. It occurs only in the trace amount, approximately 1 atom of tritium is occur per 10 power 18 hydrogen atom. So it is a trace amount isotope. This is also a radioactive isotope. Structure of this tritium isotope. In the nucleus, it contains 1 proton and 2 neutrons. And in the outermost orbital or in the orbit, it contains 1 electron. These are the types of isotope from hydrogen. So because of the presence of these three hydrogen isotope, it can exist in the naturally occurring hydrogen in the form of H2, D2, T2 and HD, DT and HT in the form of H2, D2, T2, HD, DT, HT is occur in naturally. So these isotopes have different properties are shown in the table 4.1. Look at the table 4.1 and you can see different isotopes is mentioned here: height, protium, deuterium and tritium. Atomic mass 1.008, deuterium 2.014, tritium 3.016. Okay, a number of electron, protons and neutrons. Electron, 1 electron, 1 proton. There is absence of neutron in protium. And in the deuterium, 1 electron, 1 proton and 1 neutron. In the tritium, we have 1 electron, 1 proton and 2 neutrons. It is numerically stable one, and this is also a stable one. We can't say this is stable because it is radioactive element. Their half-life is 12.3 years. And the molecular hydrogen, we can the molecular of hydrogen, the symbol protium is H, so we can give the molecular of hydrogen H2. This is D2 and this is T2. Abundance. So in the earth we can occur this 99.985%. Here this is 0.015% of deuterium in our earth. Approximately 1 atom is occurring by 10 power minus 16 hydrogen atom. And the molecular mass of protium 2.016, deuterium 4.028, tritium 6.032, and the melting point is also different from the others. So you can see the ranges here, and the boiling point also it's not same, it is different. And the internuclear distance you already know that the molecules distance between one nucleus to the another nucleus of the molecule is internucleus distance. This is same in these three cases. In the critical temperature, it is different, and the enthalpy of dissociation, the bond enthalpy of dissociation, this is nearly same, but it is not the same value, nearly same value. We have two forms of hydrogen, ortho and para hydrogen. How to find out the ortho and para hydrogen. And what is ortho para hydrogen? Generally, nucleus has a spin when the hydrogen nucleus, if it is contain one electron, then it have one spin. It may be like this or maybe in the opposite direction. This is one hydrogen and this is another hydrogen. When two hydrogen are combined together and they form a molecular hydrogen, H2 is molecular hydrogen, and draw molecular hydrogen. Molecular hydrogen. H. You can call this as H1, H2. Now, the nucleus of this hydrogen always has a spin. Okay, so we can give the possibilities of spin in this hydrogen molecule. It may be in the same direction. Both the atom contain the nucleus. It may be rotating in the same direction of spinning in a same direction, or the another possibility of the molecular hydrogen, it is in the opposite direction. So in the opposite direction means one nucleus is spinning in the clockwise direction and another nucleus is spinning, or it is spin in the anti-clockwise direction. So the nucleus has same spin or the direction is same. It is called orthohydrogen. This is orthohydrogen. So the same direction of spinning nucleus is orthohydrogen, and the opposite direction means that is para-hydrogen. Para-hydrogen. This is opposite direction. The same direction of because of the same direction of this orthohydrogen, it is more stable than the para-hydrogen. So this is less stable. So at the room temperature, normal hydrogen, the amount of normal hydrogen is contained 75% of orthohydrogen. So you took some amount of hydrogen. In that amount, 75% of that amount contain only orthohydrogen. That means the molecules which is present in that hydrogen molecules, it's rotating, their nucleus are rotating in the same direction. So this is ortho direction or orthohydrogen, we can call 75%, and the remaining 25% is para-hydrogen. That means what? They are in the anti-spin or in the opposite direction. So you can we have some method to convert one isomer into another isomer. One isomer means one orthoisomer into para-isomer, or para-isomer into orthoisomer, or from the para-hydrogen to orthohydrogen, or orthohydrogen to the para-hydrogen. Paraform can be transferred into orthoform, or we can convert this paraform into orthoform by catalytical reaction. So we used here the catalyst are platinum or iron. For converting paraform into orthoform, we use one catalyst, platinum or iron. This is one type to convert the paraform into orthoform, and the second type, para-hydrogen or paraform is heated above 800 degrees Celsius by passing electric charge. Okay, we heating this by passing electric charge. Then add this heated paraform with the paramagnetic molecules like O2 or N2, NO2 or NO. First, paraform is heated by 800 degrees Celsius or 800 degrees Celsius by passing the electric charge, and add here O2, NO2 or NO or nascent or atomic hydrogen. Nascent hydrogen or atomic hydrogen. We can add this O2 or NO2 or NO or nascent hydrogen or atomic hydrogen to getting the paraform into ortho form. Generally, ortho and para hydrogen are similar in the chemical properties. In the chemical properties, both are similar, but in the physical properties, some physical properties, they are different. For example, we can take here the melting point of para hydrogen and melting point of ortho hydrogen. So melting point of para hydrogen is 13.83 Kelvin and ortho hydrogen it is 13.95 Kelvin. So we have some difference in the melting point, that means the physical properties. And the next physical property is boiling point. Boiling point of para and boiling point of ortho. 20.26 Kelvin and the ortho hydrogen is 20.39 Kelvin. So we have some difference in the physical properties, but the chemical properties are similar or it is same. The nuclear spin are opposite direction, that's why the magnetic moment of para hydrogen is 0, but in the ortho hydrogen nuclear spin are in the same direction, so the magnetic moment of this ortho hydrogen is maybe twice of the proton. Next topic is preparation of hydrogen. We have three types of preparation. First type, electrolytic preparation or electrolysis of water. We can say this is higher purifying method of hydrogen. And the second method laboratory method, and third method industrial method. Okay, so the first preparation of hydrogen, electrolysis of water. As I already told you, the electrolysis of water, by this method you can get the highest pure hydrogen you can prepare by this method, electrolysis of water. So in the water consists, molecular formula of water, H2O. It contains 2 hydrogen. It's bonded with 1 oxygen. So we are passing electric charge through this water and dividing or separating this hydrogen from the water molecule is electrolysis of water process, by the electrolysis of water process. We used this electrolysis of water process to getting the high pure hydrogen, 99.9% high pure hydrogen we can obtain by this electrolysis of water content. Traces of acid or alkali with the electrolysis of aqueous solution. So you can take the electrolysis solution. First, for the electrolysis of water, you can take one electrolyte In electrolyte, for electrolyte we filled here water with acid or alkali group. So we took here sodium hydroxide or potassium hydroxide you can take. We took here alkali, water with alkali, H2O with sodium hydroxide. This is the solution which is filling as a electrolyte in electrolysis of water. Then we need one cathode and one anode for passing current through this electrolyte. So put here one cathode and another one anode. Cathode as iron, anode as nickel. So anode nickel, cathode iron, they are connected together and we pass through the electric charge into this solution. Now because of this discharge of electric charge by this cathode and anode in this electrolyte solution contain H2O plus NaOH or potassium hydroxide, KOH, okay, or KOH. Now the resultant of this electrolysis of water is the reaction which takes place at anode 2OH minus it's converting into H2O plus half O2 because 2OH minus is present. It is converting as H2O, H2 hydrogen and 1 O. So we have half O2 and it's donate 2 electrons. Okay, it donates 2 electron or it is releasing 2 electron from at anode. It is releasing 2 electron and the reaction which is happen at cathode, 2 molecules of water, it's accepting 2 electrons. It's accept 2 electron which is released from anode and it is convert into 2OH minus. OH minus is denoting the acceptance of electrons. 2OH minus plus subproduct. What is the subproduct? H2 is the subproduct because 2O is balanced. Totally 4 hydrogen are present. 2 hydrogen are combined with this oxygen, 2 oxygen. So it's become 2OH minus and the remaining 2 hydrogen is released as a hydrogen gas. So now hydrogen is successfully separated by this method. And the overall reaction which is happen in this electrolysis of water process is overall reaction H2O dividing as H2 plus half O2. This is the overall reaction by this electrolysis of water process. By the electrolysis of water process, we separate out hydrogen, highest pure hydrogen, 99.9% pure hydrogen. And the next method to preparing the hydrogen by laboratory. In the laboratory preparation to preparing hydrogen. And in the industrial or for the commercial use, we didn't use this electrolysis of water process. Why? Because this is not affordable in price, so it is not successful in the economical wise. Okay, so in the second type is laboratory preparation. In the laboratory preparation, hydrogen is prepared by zinc, iron and tin, which is which is dissolved with the dilute acid. And here in this case we can use zinc, iron and tin, which is dissolved with, or it is associating with the dilute acid, with dilute acid. For this laboratory preparation, we arrange one system here, round bottom flask with the stand. See this process. The round bottom flask which contain zinc, and we added here by this tube, we added dilute acid. Dilute acid, we took here, the example is hydrochloric acid, dilute hydrochloric acid added to it. So zinc plus hydrochloric acid is reacting together here, and the reaction which is happened in this round bottom flask is mentioned below. Zinc is reacting with 2 molecules of hydrochloric acid and it's released zinc chloride. 1 molecule of zinc, it is combined with the 2 molecules of chloride, and 2 moles of hydrogen is released here. So hydrogen molecule is released as a gas, it is released. Okay, so this is the process which is going on in this system. Zinc is added, or it is dissolved with together dilute hydrochloric acid. Because of this reaction, zinc chloride is formed and it is present as a solution or as a precipitate in the round bottom flask. It is settled as a round bottom flask here, and hydrogen which is released from this reaction, it is going through this tube, and it is collecting in one collecting tube or one collecting cylinder. Hydrogen is collecting here, H2. All the H2 gas are collected here from this flask. It is collecting in this system. Okay, so this is the process we use here in the laboratory preparation. So we saw the preparation 2 types. Tomorrow we can see the industrial preparation of hydrogen. Today's class over. Okay students, thank you.